The objective for this lesson is 4.5. I can compare properties of functions. Properties of functions. And they're all going to be linear functions, which means the rate of change is constant and the graph is a straight line. And all of the equations we're going to be dealing with are going to be in slope-intercept form. So let's just review. Slope-intercept form is y equals mx plus b. And we know that m is the slope, but the other word we learned for slope was the rate of change. So in a story problem, the slope we usually call the rate of change, and the y-intercept we call the initial value. So the y-intercept is our b, and we're going to call that the initial value in a story problem, or the starting value. So let's look at example 1. It says, a zebra's main predator is a lion. Lions can run at a speed of 53 feet per second over short distances. The graph shows the speed of a zebra. So this graph is for a zebra. Which animal has a faster speed and by how much? So I already know the speed of a lion. The speed of a lion is 53 feet per second. I can find the speed of the zebra by finding the rate of change from the graph. So I can pick any 2 points. I'm going to pick this point and this point. And to find the rate of change, I do change in y over change in x. So from this point to this point, I go from 472 to 236. Whoops. I have a space there. It says 236. So on my change in x, I subtract 8 to 4. So 472 minus 236 is 236 over 8 minus 4 is 4. I can simplify that to 59. So a zebra runs 59 feet per second. And I can find that anywhere on the graph. So from this point to this point, it went up 236 to the right 4. But if I would have used one of these ones that's closer together, I would have gotten up 59 over 1, or up 118 over 2, which all simplify to 59 over 1. So a zebra runs 59 feet per second, a lion can run 53 feet per second. Which animal has a faster speed and by how much? The zebra is faster. And if I subtract 59 minus 53, I get 6 feet per second. So zebras can run 6 feet per second faster than lions. Okay, example 2 says the function m equals 140h, where m is the miles traveled and h hours represents the speed of the first Japanese high-speed train. So the Japanese train is given to us in the equation. The speed of a high-speed train operating today in China is shown in the table, so that's over here. Assume the relationship between the two quantities is linear. Compare the functions y-intercepts and rates of change. So I'm going to get, do I have any paper? Another paper just so I have some more space because I wrote all over the other one. So for the Japanese train, we have the equation m equals 140h. This is in slope-intercept form. The m is the same thing as our y, it's our output. 140 is the slope, that's my rate of change, and h is my x, or my input. What's the y-intercept? The only thing I could add without changing my equation is a 0, so my y-intercept is a 0. So that makes sense. At 0 hours, the train has gone 0 miles. My rate of change is 140 miles per hour. So for the Japanese train, the initial value is 0 and the rate of change is 140. Let's look at the table to find the Chinese train. So to find the rate of change, we'll do the change in y over change in x. My x value is changing by 1 every time. My y value is going up by 217 every time. Remember, slope is change in y over change in x, so the rate of change for the Chinese train is 217 miles, or 1 hour. And then to find the initial value, I'm going to go backwards. The initial value is the same thing as the y-intercept, so I need to know when x is 0. So I'm going to go backwards 1, so that x is 0. So if I go backwards 1, I have to go backwards 217 miles on this side. 217 minus 217 is 0. So again, when the train has been moving for 0 hours, it's gone 0 miles. So if we're going to compare their y-intercepts and their rates of change, I would say both trains have a y-intercept of 0. After 0 hours, they've both gone 0 miles. Now we can compare their rates of change. The Chinese train is going 217 miles per hour. The Japanese train is going 140 miles per hour. So the Chinese train is going faster. So if we compare their rates of change or their slopes, we can say the Chinese train is faster because 217 is greater than 140 miles per hour. Okay, then part B says if you ride on each train for 5 hours, how far will you travel on each? So for the Japanese train, I can just plug into the equation. M equals 140 times h, but we're talking about 5 hours. 140 times 5 is 700 miles. For the Chinese train, we would have to, we're going 217 miles per hour. I already found that from the table. And the initial value is 0. So if I want to write an equation for the Chinese train to be y equals 217x plus 0, I don't need the plus 0. So I would plug in 5 for x, and I get 217 times 5, which is 1,085 miles. Okay, we're just going to do one more. Joan has some photos in her photo album. Each week she plans to add 12 photos. Joan had 120 photos after 8 weeks. Assume the relationship is linear. Find and interpret the rate of change in initial value. So I'm going to, let's find the rate of change. We actually already know the rate of change. It tells us in the story problem. When it tells us that she, each week she plans to add 12 photos, that is our rate of change. It tells us it tells us two things. It tells we need 2 units for a rate. Photos is one of our units, and weeks is our other unit. We're adding 12 photos per week. So our rate of change is 12 photos per week. And since it says interpret, I have to say what it means in the story problem. So I put 12 photos per week. Then I have to find the initial value. So the initial value would be how many photos she started with, or how many she had at week 0. So I'm going to first do this by making a table, and then I'll show you another way to do it. So for my table, I'm going to do weeks, and I'm going to do photos over here. And we know that after 8 weeks, she has 120 photos. So at 8 weeks, she has 120 photos. And I know she's adding, oops, you can't see. And I know she's adding 12 photos every week. So if I go backwards in my table, I'm going to have 12 photos less at week 7. So 120 minus 12 is 108. And then subtract 12. For week 6 would be 96 photos. At 5 weeks, we go backwards 12 more. She'd have 84 photos. At 4 weeks, I'd subtract 12 more. I'd have 72 photos. At 3 weeks, I'd subtract 12 more. She'd have 60 photos. At 2 weeks, I'd subtract 12 more. She'd have 48 photos. At 1 week, I'd subtract 12 more. She would have 36 photos. And I'm out of space, but at week 0, that's what I'm looking for. At week 0, she would have 24 photos. So the initial value means she started with 24 photos. Okay, it does not ask you to do this, but when you submit this question or submit this assignment on Canvas, I want you to write an equation in slope-intercept form for this situation in example 3. Given the rate of change and the initial value, put an equation in slope-intercept form and submit that on Canvas.